today in pre-cal we talked about right triangles. In particular, we talked about SOHCAHTOA. And we're going to start with the SO part. This is an acronym you should have learned in geometry, so we're going to go over some more of it today. But for the first one, S stands for sine, which is opposite over hypotenuse. The abbreviation is SIN of theta equals opposite over hypotenuse. And that's something you'll want to use over and over again. The CAH, C-A-H, is for cosine, is the adjacent over the hypotenuse. The abbreviation for that is cos of theta equals adjacent over hypotenuse. The last one is the tangent, which is the opposite over the adjacent. The abbreviation is the tan of theta equals opposite over adjacent. Again, those are formulas you'll need to memorize. Okay, if we go back to the first tab about sine, open that tab up. Let's look at a triangle. If this is my right triangle, and I do my angle here and my 90-degree angle here, the one opposite of my 90 is the hypotenuse. That's always true. The one opposite of the angle is the opposite side. Those are the two that I will need to be able to figure out the sine. For example, if I have this triangle that's a 3, 4, 5 triangle, where this is my 90-degree angle, and this is my angle theta, then the sine of theta equals, the opposite would be 3, and the hypotenuse would be 5. So it's 3 over 5. We don't care about the 4 in this case. If I close that one up and look down at the next one, which is cosine, I'm going to draw a triangle. My 90-degree angle, my angle. This would be my hypotenuse. If I go across from the angle, that would be my opposite, which is the one I just showed you. So this one right here would be adjacent. Another word for adjacent is just next to or beside. If we look at an example of that, I'm going to do another 3, 4, 5 triangle. This is my angle theta. This is my 90 degrees. That's my hypotenuse, my opposite, and my adjacent. The cosine of theta is always adjacent, which would be the 4, over hypotenuse, which would be the 5. And that's my answer. The last one is tangent. I'm going to draw another triangle for reference. A 90-degree angle, our angle, and we need the opposite and the adjacent side for that one. An example, this triangle here, where my hypotenuse is 10, my opposite is 8, and my adjacent is 6. So the tangent, which is opposite over adjacent, is 8 over 6, which reduces to 4 over 3. And that would be my adjacent. Also, right here, I need you to include that the tangent of theta is also equal to the sine of theta over the cosine of theta. That's a formula that you need to know. And right now, I just want you to accept and memorize that. Eventually, we will prove and show why that is true. Okay, going back to the top of our foldable here, we also need to talk about the inverses. The inverse of sine is what is called cosecant. And the cosecant is abbreviated CSC of theta equals 1 over the sine of theta, which is equal to the hypotenuse over the opposite. Okay, that looks really complicated. It's just saying that this is the opposite of this, which is why I just flip hypotenuse over opposite. That's cosecant. The next one is secant. Secant is opposite of cosine, and the secant is abbreviated SEC of theta equals 1 over cosine of theta, which is the same as the hypotenuse over the adjacent. Again, it's the opposite or the reciprocal of this one. The last one is the cotangent, and cotangent is abbreviated COT. The cotangent of theta is 1 over the tangent of theta, which is also the adjacent over the opposite. Okay, let's look at some examples of how we put that into practice. If I go across this whole first tab right here, I'm going to take my sine, which I know to be 3 over 5, and then my cosecant of theta is just that being flipped. So instead of 3 over 5, it's 5 over 3. I can't get that all into this view, so you'll have to look across at your own foldable. But the next one would be the secant of theta, which is the opposite of 4 over 5, which would be 5 over 4. And Finally, the cotangent, the very last one, is the opposite of tangent. And so instead of being 4 over 3, it's going to be 3 over 4. And I just flip those. That's the way to get that. Right here, your formula that you need is that the cotangent of theta equals the cosecant of theta over the secant of theta. That's another one that you'll just need to accept for now. That was it for today's lesson. The assignment was A13, page 308, 1 to 12. Good luck. Let me know if you have questions.